Hello my dear students, once again welcome back for the continuation of chapter 8 in chemistry, that is hydrogen chloride. Today we shall discuss about the physical and chemical properties of hydrochloric acid. Please do not get confused because I have not mentioned the physical properties of hydrochloric acid on the blackboard. Before I start this, I would like to recapitulate that we have done in previous class. As you know that this hydrochloric acid can be prepared by dissolving hydrogen chloride gas in water by means of an inverted funnel arrangement. This funnel arrangement prevents backsuction of water, and it also provides large surface area for the absorption of hydrogen chloride gas to form hydrochloric acid. Now let's move on to today's topic, physical properties of hydrochloric acid. Pure hydrochloric acid is colorless liquid, but commercially available hydrochloric acid is slightly yellow in color due to presence of ferric chloride as an impurity. Hydrochloric acid is sour in taste. It has slightly pungent odor, and this hydrochloric acid is corrosive in nature, and hydrochloric acid is highly soluble in water. Now, chemical properties of hydrochloric acid. Dilute hydrochloric acid. Now, acidic nature. Acidic nature. Whenever acid like hydrochloric acid, sulfuric acid, nitric acid, whenever they dissolve in water, they produce hydronium ion as the only positively charged ions, and these hydronium ions are the responsible for the acidic properties of the acid, color changes of the indicator as an electrolyte. As you can see here, acidic nature of hydrochloric acid. Hydrochloric acid, when it dissolves in water, it ionizes and to form hydronium ions as the only positively charged ion, S3O positive. These hydronium ions are responsible for the acidic properties of hydrochloric acid. These hydronium ions are responsible for the color changes of the indicator, and these ions are responsible for the good conductor of electricity, and it acts as an electrolyte. Now here next, reaction with active metals. Active metals means metals which are found above hydrogen in the activity series. You know, activity series of a metal is the list of metals which are arranged in the decreasing order of their reactivity. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, silver, mercury, gold, platinum, etc. And the metals which are above hydrogen in the activity series, these are the active metals. Whenever these active metals react with dilute acid, they produce hydrogen gas, and the salt is formed. Another product is salt. If you use hydrochloric acid, you will get chloride salt. If you use dilute sulfuric acid, you will get sulfate salt. But nitric acid, being powerful oxidizing agent, it does not produce hydrogen gas. It oxidizes hydrogen to water molecule. As you can see here, reaction with active metal. Reaction of dilute hydrochloric acid with active metal. Here iron, which is above hydrogen in the activity series, when iron reacts with hydrochloric acid, it produces hydrogen gas, and chloride solid is formed, that is ferrous chloride. Here the valency of iron is 2 and chloride is 1. On interchanging their valency, the molecular formula of ferrous chloride is FeCl 2. Zinc is also above hydrogen in the activity series. When it reacts with dilute hydrochloric acid, hydrogen gas is zero and the salt is formed, that is zinc chloride. Here the valency of zinc is 2 and chloride is 1. On interchanging their valency, the molecular formula of zinc chloride is ZnCl2. Now next year, reaction of dilute hydrochloric acid with bases. You know, bases are metallic oxide, metallic hydroxide or ammonium hydroxide. Whenever dilute acid reacts with bases, they produce salt and water molecule. All metallic oxide, all metallic hydroxide are bases. Here the reaction of dilute acid with bases. Copper oxide is the base. Here, copper oxide when reacts with dilute hydrochloric acid, it produces copper chloride and water molecule. Here, salt and water, these are the products formed whenever bases react with acid. Here the valency of copper is 2 and oxide is 2. Both the valency of copper and oxide is 2. And on interchanging their valency, 2 cancel. So the molecular formula of copper oxide is CuO. Here the valency of copper is 2, chloride is 1. On interchanging their valency, the molecular formula of copper chloride is CuCl2. Here, similarly, sodium hydroxide is a strong base. When it reacts with hydrochloric acid, we will get salt and water molecule. Here, salt, sodium chloride. Here, sodium combines with chlorine. Here, this is basic radical, this is acidic radical. This basic radical, sodium combines with acidic radical of this acid. Sodium combines with chlorine, sodium chloride. Hydrogen combines with hydroxyl, water molecule. Here the valency of both sodium and chloride is 1. On interchanging their valency, the molecular formula is NaCl plus H2O. Here sodium hydroxide and hydrochloric acid, when they react with each other, will get sodium chloride and water molecule. Now here, reaction with carbonate or bicarbonate salt. Whenever carbonate or bicarbonate salt react with dilute acid, we'll get carbon dioxide gas, water molecule and this salt. 3 products are formed. First, carbon dioxide gas is evolved. Other 2 products are salt and water molecule. If you use sulfuric acid, you'll get sulfate salt. If you use hydrochloric acid, you will get chloride salt. If you use nitric acid, you will get nitrate salt. Here the reaction of dilute hydrochloric acid with carbonate and bicarbonate salt. As I have already told you, carbon dioxide gases evolve and other 2 products are salt and water. Here in this case, we are using hydrochloric acid, so we will get chloride salt. Here sodium carbonate. Here the valency of sodium is 1. This is basic radical. Here carbonate is acidic radical. So its valency is 2. On interchanging their valency, the molecular formula of sodium carbonate is Na2CO3. When this sodium carbonate reacts with dilute hydrochloric acid, we will get carbon dioxide gas. Carbon dioxide is a colorless, odorless gas. It is neither combustible nor supporter of combustion. It turns lime water milky and has no effect on acidified potassium dichromate. And this carbon dioxide is one of the greenhouse gases. This gas is responsible for global warming. Your sodium carbonate, when reacts with hydrochloric acid, will get carbon dioxide carbon dioxide gas, and other 2 products are salt and water molecule. This sodium combines with this basic radical combines with the acidic radical of this acid. Hydrogen 1, chloride 1. This sodium combines with chlorine, so we'll get sodium chloride. Both the valency of sodium and chloride is 1. On interchanging their valency, the molecular formula is NaCl. Here, bicarbonate, same products will form. Sodium bicarbonate, HCO3 or hydrogen carbonate. When reacts with hydrochloric acid, we'll get sodium chloride, water molecule and carbon dioxide. Now, whenever sulfite, SULPHITE, sulfite or bisulfite salt, whenever they react with dilute acid, we get sulfur dioxide gas. Other two products are salt and water molecule. If you use sulfuric acid, you will get sulfate salt. If you use hydrochloric acid, you will get chloride salt. If you use nitric acid, you will get nitrate salt. Here the reaction of dilute hydrochloric acid with sulfite and bisulfite salt. Here, potassium sulfite, K2SO3. The valency of potassium is 1. This potassium is basic radical and sulfite is acidic radical. Valency 2. On interchanging their valency, the molecular formula of potassium sulfite is K2SO3. When it reacts with sulfite salt, when reacts with hydrochloric acid, we will get sulfur dioxide gas, SO2. Sulfur dioxide is a colorless gas, but it has a smell of burning sulfur. And this sulfur dioxide is an acidic gas because it turns blue litmus paper red. This sulfur dioxide also turns lime water milky. And this sulfur dioxide changes yellow or orange color of acidified potassium dichromate green. Whenever sulfite or bisulfite salt react with dilute acid, we will get sulfur dioxide and other two products are salt and water molecule. Here you can see your hydrochloric acid, so we'll get chloride salt. Here potassium, this potassium basic radical combines with acidic radical of this hydrochloric acid. So here hydrogen 1 chloride 1. Here potassium combines with chlorine, so potassium chloride KCl. Similarly, now sodium bisulfite. Sodium hydrogen sulfide. When reacts with hydrochloric acid, will get sulfur dioxide, water molecule. Here the valency of sodium is 1, bisulfite is 1. So it combines with this sodium combines with this basic radical, sodium combines with acidic radical of this hydrochloric acid, chloride, so sodium chloride. Now next here, reaction with sulfide salt. Whenever SULPHIDE, whenever sulfide salt reacts with dilute acid, we get hydrogen sulfide gas. Hydrogen sulfide gas has rotten egg smell and it changes lead acidic paper silvery black. If you use dilute hydrochloric acid, you will get chloride salt. If you use sulfuric acid, you will get sulfate salt. But in this case, we don't get water molecule. Now reaction of dilute acid with sulfide salt. Ferrous sulfide. Here both the valency of iron and sulfur is 2. On interchanging their valency, this 2 cancel. So the molecular formula of ferrous sulfide is FeS. When reacts with hydrochloric acid, we will get hydrogen sulfide gas, H2S, which has rotten egg smell. Here the valency of hydrogen is 1, sulfide is 2. On interchanging their valency, the molecular formula of hydrogen sulfide is H2S. Here the valency of hydrogen is 1, chloride is 1. Here this hydrogen is basic radical, this chloride is acidic radical. Here this iron is basic radical, this sulfur is acidic radical. This basic radical combines with acidic radical of this acid. So FeCl2, because the valency of iron is 2, chloride is 1. On interchanging their valency, the molecular formula is FeCl2. Now similarly, copper sulfide when reacts with hydrochloric acid will get hydrogen sulfide and copper chloride. Here both the valency of copper and sulfur is 2. On interchanging their valency, 2 cancel, so copper chloride. Now reaction of hydrochloric acid with nitrates. Here hydrochloric hydrochloric acid, whenever react with silver nitrate solution, it gives white precipitate of silver chloride. White precipitate and insoluble white precipitate of silver chloride is formed. Here the valency of silver is 1, nitrate is 1, hydrogen 1, chloride 1. Here this basic radical of this salt, silver, combines with acidic radical of this acid chloride. So silver combines with chlorine. So silver chloride, both the valency of silver and chloride is 1. A white precipitate of silver chloride is formed. And this white precipitate is insoluble in all the acid. However, it is soluble in excess of ammonium hydroxide, thereby forming a colorless solution diamine silver chloride. When the silver chloride is treated with excess of ammonium hydroxide, it gives a colorless solution, which is a complex diamine silver chloride. And if you add again dilute nitric acid to this solution, again a white precipitate reappears. White precipitate of silver chloride reappears. Now next your reaction of dilute hydrochloric acid with sodium thiosulfate. The molecular formula of sodium thiosulfate is Na2H2O3. When the sodium thiosulfate reacts with hydrochloric acid, it gives yellow precipitate of sulfur, and other three products are sulfur dioxide, water molecule, and sodium chloride. Now we have specific reaction of concentrated hydrochloric acid. Here the reaction of concentrated hydrochloric acid with strong oxidizing agent like lead dioxide, trilead tetroxide, or red lead, manganese dioxide, or manganese peroxide, potassium permanganate, or potassium dichromate. Whenever this strong oxidizing agent, they treated with concentrated hydrochloric acid, they give greenish yellow chlorine gas. Chlorine is greenish yellow gas. It is acidic gas because it turns blue litmus paper red. It turns stars iodide paper blue-black. Now lead dioxide, when it reacts with concentrated hydrochloric acid, here lead combines with chlorine, so we will get lead chloride. Here oxygen combines with hydrogen, water molecule, and the gas is chlorine gas. Here similarly, red lead PbO3O4, trilead tetroxide. Red lead when reacts with concentrated hydrochloric acid, greenish yellow chlorine gas is evolved. This lead combines with chlorine, lead chloride. This oxygen combines with hydrogen, water molecule. And manganese dioxide when reacts with concentrated hydrochloric acid, greenish yellow chlorine gas is evolved. This manganese combines with chlorine or chloride of this hydrochloric acid, so we will get manganese chloride. Oxygen combines with hydrogen, water molecule. Here potassium dichromate, K2Cr2O7. K2Cr2O7. Here potassium dichromate contains two basic radicals. So first chlorine gas is evolved, greenish yellow chlorine gas is evolved. This potassium combines with chloride of this hydrochloric acid, potassium chloride. Chromium combines with chloride of this hydrochloric acid, chromium chloride. Then oxygen combines with hydrogen, water molecule. Here similarly, here potassium permanganate contains two basic radicals, potassium and manganese. When it is treated with hydrochloric acid, greenish yellow chlorine gas is evolved. Potassium combines with chloride of hydrochloric acid, potassium chloride. Manganese combines with chloride of hydrochloric acid, manganese chloride. Oxygen combines with hydrogen, water molecule. Bleaching powder. Here, greenish yellow chlorine gas is evolved. This calcium combines with chloride of hydrochloric acid, calcium chloride. Oxygen combines with hydrogen, water molecule. Here, reaction with strong oxidizing agent like lead dioxide, red lead, manganese dioxide, potassium formate, potassium dichromate. Check. Here, red lead when reacts with concentrated hydrochloric acid, greenish yellow chlorine gas is evolved. This basic radical lead combines with chlorine, lead chloride. This oxygen combines with hydrogen, H2O, water molecule. Similarly, your manganese dioxide when it is treated with concentrated hydrochloric acid, chlorine, greenish yellow chlorine gas is evolved. This manganese combines with chlorine, manganese chloride, because the valency of manganese is 2, chloride is 1. On interchanging the valency, the molecular formula of manganese chloride is MnCl2. This oxygen combines with hydrogen, water. Then potassium dichromate, K2Cr2O7. Here, when it is treated with concentrated hydrochloric acid, chlorine gas is evolved. This potassium combines with chloride, potassium chloride, chromium combines with chloride of this hydrochloric acid, chromium chloride, oxygen combines with hydrogen, water molecule. Now next here, reaction of concentrated hydrochloric acid with concentrated nitric acid. When 3 parts of concentrated hydrochloric acid reacts with 1 part of concentrated nitric acid, it produces aqua regia. Now what is aqua regia? Aqua regia is a mixture of 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid, and it produces nascent chlorine. This nascent chlorine dissolves noble metals like gold and silver. Here, 3 parts of concentrated hydrochloric acid reacts with 1 part of concentrated nitric acid. It produces nascent chlorine, and this nascent chlorine is highly reactive atom. And this dissolves noble metals like gold, platinum, and etc. When gold reacts with this nascent chlorine or aqua regia, it produces auric chloride. The valency of gold is 3 and chloride is 1. On interchanging their valency, the molecular formula is AuCl3. Similarly, platinum also dissolves with aqua regia and it produces platinum chloride. The valency of platinum is 4 and chloride is 1. And this is nitrosyl chloride. Now next, test for hydrochloric acid. Here, this hydrochloric acid gives a dense white fumes of ammonium chloride when a glass rod is dipped in ammonia solution brought near the jar containing hydrochloric acid. It gives dense white fumes of ammonium chloride when a glass rod dipped in ammonia solution is brought near the mouth of the jar containing hydrochloric acid. And hydrochloric acid, next test, it gives greenish yellow chlorine gas whenever it reacts with manganese dioxide. And third test, it gives white precipitate or coating white precipitate of silver chloride when this hydrochloric acid reacts with silver nitrate solution. Now next your uses. Please you go through the book. Dear children, here we have come to the end of today's online class. Thank you very much.